So we started with the same object. I can simplify exponential expressions using multiplication properties of exponents. Today we're going to finish with the multiplication properties, and we're going to finish with the last two properties. In your Freyer model, what is the main concept for today, everyone? Main concept. Exponential expression. So in the center of your Freyer model, you're going to write exponential expressions. All right? Definition. You fill it in without looking at your notes. Ready? Go. Hint, hint, just in case, wink, wink, Friday we have a pop party and I ask you to give me definitions for the last three definitions we covered. Good. Copy that. Okay, let's see if your noodle kind of retains some of it. An exponential expression is a numerical or variable expression raised to a power greater than 1. Write a couple of examples of your own, non-examples. And for critical attributes, so that it can stick, hopefully next time instead of remembering the definition, you remember the hashtags. What would be one hashtag? Look at the non-examples, look at the examples. So you never one hashtag. Okay, who has one? Yes. Power raised greater than 1. Okay? It's a good hashtag. Look at the non-examples and look at the examples. What will be the other one? No. Bam. Hashtag expressions. Okay, we got this? Yes, Mr. Q. All right, good. All right, so let me move on. You don't copy the next steps. I'm just going to show you the steps that we wrote last, when was it, Monday? Yes. All right, so let's see. The steps I gave you were identify the exponential expression is a product of powers, power, power, power products. So we already covered product of powers. Today we're going to look at power of power and power of products. From there, use appropriate property to compute and simplify. Okay? But before anything else, just FYI, once again, anything without an exponent has a 1. And we're still using commutative and associative, yes? From there, we introduced the first product of powers property. I gave you guys examples. We came up with a rule. Is that correct? From there, I gave you guys practice problems. We became experts at it, yes? However, I want to get to this problem. Copy this one, please. Example 3A. If it doesn't fit under the Freyer model, you can copy it in the back if you need more writing room. It says, example 3A. Light from the sun travels at about 1.86 times 10 to the 5th miles per second. It takes about 15,000 seconds for the light to reach Neptune. Find the approximate distance from the sun to Neptune. Write your answer in scientific notation. Copy that, and then I'll go over the first steps, and you'll finish it off. Go. All right, so writing utensils down, let me elaborate on scientific notation. Here it goes. Scientific notation. Man, my computer's so slow. Okay. Wow. Scientific notation. Let me try it again. Maybe this is one of the computers that I draw like a nice picture, and all of a sudden, like a nice Michael Jordan dunking, and all it shows is this. Jordan. I know, right? Anyways, scientific notation is used in the scientific world. They use it to write big numbers in smaller portions. So, for example, if you have 380 trillion, 455 billion, 385 million, 265,486, and they wanted you to crunch that to a smaller number, then they use scientific notation. For example, let me think of a random number 2,300. Michael Jordan. Anyways, if I'm thinking of this big number and I wanted to crunch it and make it a little bit smaller, to make it in scientific notation, they use base 10, because base 10, when you multiply this base 10, it adds a 0 to the number. Does that make sense? Yeah. So, for example, in order to make it scientific notation, I need a decimal and base 10. On the decimal, I can only have one digit on the left side and the rest of them on the right. Therefore, I'm going to make this into scientific notation. Here he goes. Does everybody see the invisible decimal here? Yes. No, it's not there. Now do you see it? Okay, so now I'm going to move this to the left 1, 2, 3 times so it can fit this pattern, right? So now my decimal would be 2.3. How many times did I move the decimal over? That goes right here. Let me show you another one. 485,700. I'm going to make this into scientific notation. We need a base 10, and we need a decimal, yes? How many numbers on the left of the decimal? Only one digit, yes? Therefore, I'm going to move the decimal 1, 2, 3, 4, 5 times. That goes right here. Therefore, my decimal is 4.857. You got it? All right. Now let's go to the problem at hand. It says, the light travels so fast that they have to write it in scientific notation, 1.86 times 10 to the 5th per second. So in 1 second, it travels these many miles. But they want to find out how long it takes to travel how many miles in how many seconds? How many miles? In how many seconds? 15,000. So what do we need to do to this? If this is 1 second, what do we need to do? Multiply times 15,000. But here they want us to write it in what? So I want you to write this one in scientific notation really quick, and then we'll continue with the next step. Copy that and go. All right, let's see. Base 10, yes. Move the decimal how many times? 1, 2, 3, 4. That goes right here. And my decimal is 1.5. Hands if you got that. Okay? So, that's still in the parentheses. Bring this one down. 1.86 times 10 to the 5th. So, question. Do we have multiplication here in between these two? Between these two? In between these two? So can we move stuff around now? Yeah, see if you can do the next step. Move stuff around, commutative property, and then do associative property, and then we'll finish it together. Commutative property, you should have written 1.86 times 1.5 times 10 to the 5th times 10 to the 4th. Hands if you got that far. Okay? Associative property, we need to group this, yes? So numbers with numbers, same basis with same basis. Do we know what this is? Tell your neighbor, please. What does this become? 10 to the 9 times. These we do have to multiply, yes? 1.86 times 1.5. Multiply those, see what you get. Okay, tell your neighbor what you got. Nina, what'd you get? 2.79. Hands if you got that. Therefore, this is how many miles the sun is away from Neptune. Everybody got it? But notice that the process, now that we have the property and we have our properties to use, we can apply it to any word number now that we know how to change into scientific notation. Are we there? All right. So, set that aside. I want you to pay attention, please. Now, here go a couple of rules that they gave you last year. Like I said, they did give you those to remember, but I'm just going to show you really quick how you can actually come up with a rule using the product of powers. Look up, please. Do you agree that if they have the same base, you add the exponents, yes? Let me show you with numbers. 3 to the second times 3 to the 0 is the same as 3 to the second plus 0, is that correct? Which is 3 to the second. Are they the same base? Don't we add 2 plus 0? Yes. Don't we get 2? Yes. So what is 3 squared? 9. So this is 9 and this is 9. Do you agree with that? Okay. But this says 9 times something gives me 9. What is that number? 1. Okay? Let me show you with a different number. 5 to the second times 5 to the 0 is the same as 5 to the second plus 0, which is still 5 to the second. What is 5 to the second? 25. This is still 25. This is still 25. Times what gives me 25? Tell your neighbor, by looking at this rule, by implication, what would be a general rule for that? Talk it over with your neighbor. All right. Rule, anyone? Yes?
Anything to the 0 power is 1.
Anything to the 0 power is 1. So, for example, Jeremiah to the 0 power is 1, okay. How about 1 million to the 0 power? X to the 0 power. So anything to the, okay, we got that. All right, look up, please. Let me continue. So with this same idea, look at this. 3 to the second times 3 to the first is 3 to the second plus 1. Is that correct? Which is 3 to the third. What is 3 to the third? 27. This is 27, and this is 9. 9 times what gives me 27? Okay. Let me use a different number. 4 to the second times 4 to the first is 4 to the second plus 1, which is 4 to the third. 4 to the third is 4 times 4 times 4, which is 64. This is still 64, but this is 16. 16 times what gives me 64? And I can give you several examples of those, but if we can generalize the idea, tell your neighbor what will be the general idea. All right. Rule, anyone? Yes?
Anything to the power of 1 is unnecessary. The power is
Okay, let's make it a little bit simpler. Jocelyn? Okay. Yes? You ever hear that? Yeah. Say it a little bit louder for everyone. She's on. And then she's on. Any number to any number to the power of 1 is itself. We got it? So x to the power of 1 is? That's why anything that does not have an exponent, we put a 1. Does that make sense? All right, so we're done with all this messing around. Let's start with our last properties. Power of powers property. Write this down, please. And if it doesn't fit in the front, write in the back. Example, Keel. And once again, this is where you start working, and I'm just gonna be quiet and have your noodle do the work. Yes? Yes, Mr. Q. Good. Open parentheses, 2 to the third, close parentheses, raised to the fourth power. Underneath that, open parentheses, x to the second, close parentheses, raised to the fifth power. Underneath that, open parentheses, 3 to the fourth power, close parentheses, bless you, raised to the fifth power. And notice what the words that I'm using. Whenever there's an exponent outside a parentheses, we call it raised to another power, whatever the power that be, right? You ever hear that? Okay. All right, so let me give you the rule. Pay attention, and then I'm going to have you share with your neighbor, and then we'll come up and write our rule down. Here we go. Writing utensils down, look up, please. Here it goes. All right, talk it over with your neighbor. All right. Asterisk, heart, So, what is it that we're doing? Did I say when we do a parentheses and exponent outside, what is that called? Raising. So let's start our definition. When raising, what are we raising? What are these called, whatever's inside of the parentheses? They're called what, everyone? X what? Exponential expressions. When raising exponential expressions to another exponent, comma, what do we do? You multiply what? The exponents. 10Q. 10Q? 10Q? All right, here we go. Now, why does it work? Check this out. As you're copying the rest of it, that's fine. What is the exponential expression here first? 2 to the what? 2 to the third. But it tells me to repeat it how many times? 2 to the third, 2 to the third, 2 to the third. What was the first property that we learned? Product of powers property that says if they have the same base, what do we do to the exponents? Add them. So same base, 3 plus 3 plus 3 plus 3, that is? That just happened. I want you to do the rest, this one here and this one here, see if it works also with the product of powers property. I mean, the shortcut is power of powers, right? But see if you can do the product of powers and see if it works. Yes? Yes, Mr. Q. All right, good. This one was x to the second, x to the second, x to the second, x to the second, x to the second. Are they the same base? Yes. 2 plus 2 plus 2 plus 2 plus 2? Yes. Have we got it? Now, in the past, one of the, I guess, a phrase that I remind my students in case they get confused with the work, I tell them, when in doubt, factor out. When you have numbers being multiplied like this, these are called factored form, or factors. Kind of like if I say, what are the factors of 20? 4 times 5, 2 times 10, 1 times 20. Because they're numbers that are multiplying. That's why they're called what? Factors. When in doubt, factor out and see if it works. Okay? We got this? Ready for practice? All right, here we go. Copy these, please. Example 1A and 1B. 4A and 4B. Example 4 is parentheses 5 squared to the 4th power, and then 4B is 4 cubed raised to the 0 power. Copy that. You got 20 seconds. Go. Okay, here we go. A, who got 5 to the 8th? Okay, good. B, who got 4 to the 0? Good. That is wrong. Who got 1? That is correct. Remember, from now on, now that you know the rule, now I want to see the simplification after. Okay? Okay, let's do another one. Copy this one. Example 4C. Let's see how you do with that one. See what I did? Be nice. What? No. Look up, please. Notice here we have a lot of stuff going on. I want you to do this part first. Bring it down. Once you do that part first, bring this one down, and then you can finish it off like that. Copy that and go. All right. Let's see. Here, power of power, so therefore this is x to the negative 15. I bring this down. Are these the same base? Negative 15 plus 4, that is negative 11. Hands, have you got that? Okay. All right, let's do another one. Copy this next one, please. Yes. We still haven't covered negative exponents. We will get there. But I know some of you are already writing it the other way. That's fine. But I want to make sure that we do the property first before I start asking you to do the next step. Let's do number 5C. It says a to the 3rd raised to the 4th power and a to the negative 2 raised to the negative 3 power. 10 seconds. Okay, check with the neighbor. All right, here we go. This one becomes a to the 12th, yes? Times. This one becomes a to the 6th. Same base, this is 18. So far so good? All right. Let's do one more and then we'll move on. Actually, no, let's move on. Copy this one. Power of products property. Last property for the day for multiplication. Power of products property. Example, supercube. Parentheses, 2, x to the 4th, close parenthesis, raised to the 5th power. Underneath that, parenthesis, 7 cubed, x to the 2nd, y to the 4th, z to the 8th, and all that raised to the, give me a number? 6. everything. Oh, wow. All right.
Actually, nobody said six.
I know, right? That's weird. All right, writing utensils down, look up. Here it goes. So, here goes the rule. Tell your neighbor the rule, please. Okay, start us off with our rule, please. Yeah?
Okay, when numbers are in parentheses, like, when there's a lot of them in parentheses,
Okay, when raising exponential expressions with what?
in parentheses,
I know, but you were saying with a lot of what?
with a lot of, numbers.
With many
Exponents.
variables and numbers, comma, what do we do?
Multiply all of them by we'll raise all of them to the number.
Raise all exponents to the power. Is that clear enough?
No.
Okay, it says, when raising exponential expressions with many variables and numbers, raise all exponents, all of these, raise them to the power, what? The power or exponent outside the parenthesis. 10Q. Home plate, finish up the last problems from both sides of the sheets. Have a good one, guys. Enjoy your home plate. See you guys tomorrow, Mr. Q.